Okay. Now the question is, as the Fock state is a squeeze state, so we must show this, and we must show delta x1 is square is less than 1 over 4, delta x2 square is less than 1 over 4. So consider this equation delta x1 square, which is equal to x1 square average minus x1 average square, and putting the value because now this is a Fock state, so we must take the cat and bra must be a Fock state and number state. So we must multiply this side, and this the average must be a Fock state. So this is n and this is n and n and n. So this is a very simple method that we know about this, and putting the value of x1, and x1 is equal to 1 over 2 and 2a plus a dagger. So if we take square, so 1 over 4 a plus a dagger whole square n, and similarly this is the value of x1. And now let take 1 over 4, and here you can take 1 over 4. If I take this from the square, then 1 over 4 and 1 over 4 can be considered here. 1 over 4 can be taken outside. So this is the now if I take the square, because this is if we expand this square, then we can get a square plus a dagger square plus a dagger plus a dagger a, and then I write this directly in the coherent state separately, because this sorry, the number state or the Fock state, because this is n and this is n, which is applied from both sides. So n a square n and n a dagger square n. So and then a dagger and a dagger a. And here we can also take n a, and this is n whole square. Now n a square n and this, but one thing is here a dagger, we can take a dagger, the value of 1 plus a dagger a. So I have directly put the value of a dagger here, then we have 1, so the expectation value and this thing, and then we can take the expectation value of this. So this is n a dagger a, and this thing remains the same, and further minus n a n and n a. Now the point is how to solve this thing. So we know about the previous knowledge that if a is applied on this state, then we can get n under root and one photon is reduced, one state is reduced. So n minus 1. And similarly, if we have a dagger and if we apply this on this state, then n plus 1 under root and 1. So this is a very well-known thing that we know about this. So the first term, if we take the first term, so the first term is n a square and n. So here it means that we can write this n a and n. Then first we apply this annihilation operator on this state, then we have n and a, then we can get n under root and this n minus 1. So n under root can be taken outside, and n a annihilation operator 1 is remaining, and this n minus 1. And now further, if we apply this annihilation operator on this, then we can get n minus 1, the eigenvalue, and this one state must be reduced, so this n minus 2. So now n and n minus 2, these are orthogonal states, so it goes to 0. And so this term goes to 0. And similarly, if we apply this a dagger square to this, then we can get this term n plus 1 by. Similarly, you can do this. So the state is n plus 2, and this is 0. And for this is 1, this is a normalized state. And similarly for a dagger a, if we apply a firstly, then we can get n, and then if apply a dagger, then we can get 2n and nn. And this is very simple. For this state, n and a dagger a n. First apply this. So if we apply this on this, we can get eigenvalue n under root, and we have a dagger and n minus 1. Now we apply a dagger on this. So if we apply a dagger on this, then we can get n minus 1 plus 1, the eigenvalue, and n minus 1 plus 1, because it increases one factor, the state. And here this can be cancelled out and this can be cancelled out, and you can get n under root here and n under root this one, and n. So this is equal to 1, and you can get n here. So this is very simple, that you can point out n, 1 from this and 1 from this, then you can get 2n n. And similarly uh, here if apply this, so you can get n minus 1, this goes to 0, and this also goes to 0. Then you have only this term goes to 0, this term, and you have only 2n, and this is equal to 1. So you have 2n plus 1 and 1 over 4. So this is delta x1 square is equal to 1 over 2n plus 1. And similarly, if you apply and you can find out delta x2 square, which is equal to 1 over 4 2n plus 1. This similar method you can apply. So the condition for the squeeze state is delta x1 square is less than 1 over 4 and delta x2 square is less than 1 over 4. But here we get delta x1 square as 1 over 4 2n plus. So the condition is not satisfied, and we can say that the Fock state is not a squeezed state.